Hello everybody, my name is Tim and I'm going to be programming this TI-84 calculator. So if we hit the program button, we'll go into our program menu. I'm going to go ahead and create a new program, and what we're going to make is Zelda. That's right, we're going to be programming Zelda. So to start off with, let's go ahead and what we're going to do is we're going to use just the character output. So we're going to go ahead and just clear the screen, and then let's see, we're going to need a couple of variables for the coordinates. So let's start link off kind of in the center somewhere, and wherever link is, let's put an actual character. So the x and the y are the coordinates, so I'm gonna have link at 4x and 4y, because that's kind of, it's not in the very center of the screen, but it's like close enough. And then we're gonna output whatever those coordinates are. So whatever y and x happen to be, we're gonna output link to be in that position. So let's make him, at least for now, I'm thinking just a theta. So when you do output, output is a command that it takes 3 arguments. So the first argument here is going to be the y value. It's going to be how far up and down on the screen that we're going to write what we're trying to write. And then the x value is how far from the left side of the screen we're going to write it. And then the third argument is what we're actually writing. So I can put a theta in quotes like that and then end the parentheses, but you don't actually need to end all the quotes in parentheses. When you finish a programming line in TI Basic, it'll automatically know just to finish everything. So right now, if we were to run this, so I'm going to exit and I'm going to go down to Zelda. So right here, it's the last program I have here, because it starts with a Z, and when I run it, the program finishes after it outputted a theta at 4, 4. So let's go back and edit it again so that we can actually continue, moving around or something like that. So I'm going to add in another line, and I'm going to put a loop here. So while one, this will be like an infinite loop. So we'll just continue outputting. So I'm going to put 7 is end. So what happens here is a while loop is it's a loop that continues going until, like, if I had a statement here like 1 while 1 equals 1. Well, that statement's true. Like, I could put a variable like a or something, like while 1 equals a. But if I just have something that's always true, then it will always be in the loop until I actually, exit the program manually. So I'm gonna just put a 1, because when you just have a 1, that's what a true statement evaluates to. It actually takes if I had 1 equals 1 here, the code would actually evaluate this statement right here, and if it's true, it'll return a 1. If it's false, it'll return a 0. So if I just have a 1 there, it thinks that there's just a true statement here, and that's all that matters. So we'll always be in this loop. So the reason why I want to make a loop is because I'm going to insert, inside this loop, I'm going to insert the ability to change your coordinates. So we're going to be able to move around. So I'm going to go into program here, and I'm going to use this a certain type of input command. It's not going to be the input where you write in something. It's actually going to be get key. And so the whole calculator is numbered with the keys. So this is key 1 1. This is key 1 2, 1 3, 1 4, 1 5. This is key 2 1, 2 2, 2 3, 2 4. This is actually 2 5, and this is 2 6. This is 3 1, 3 2, 3 3, 3 4, and so on. So I'm going to use get key, and I'm going to store that number that it returns when I press a button. The next time the code gets to get key will give a number. So if I don't press any button at all, it'll actually just give it 0. So I'm going to actually store that into the variable a. So if I don't press something, a after this line of code will be 0. But if I pressed something, a will be, a will actually be whatever I pressed. So if I want to move to the right, we're going to use 26. So if a equals 26, with an if statement, then it checks it'll check if this statement is true, and if it is, it'll run this next line of code. If it's not true, it just skips the next line of code. If I use an if then with an end statement, that's different. It can do multiple lines of code, but if you don't use a then, in TI Basic, it'll just do this one next line of code. So if a actually equals 26, then I'm going to go and I'm going to actually add to the x value. So x plus 1 stores x. So now x is going to be increased. And if you want to know where the store button is, it's right here. That's how you store. And for all the commands I'm getting, I'm pressing program, by the way. If you didn't know that, if you press program, this is where I get the menu from. So I'm gonna run Zelda, and now if I press to the right, it should move to the right. And there we go, it works. Okay, so we're gonna go in here, and I'm going to add in all the other directions. So if a equals 24, then we're going to go to the left. If a equals 34, then y is going to increase because we're going to go down. And if a equals 25, then that's the up arrow, so we're going to decrease y. And let's try this. So if I go up, yep, can go up, right, down, left. So good, I can control everywhere I'm moving. Now if I go off the screen, it'll get an error. Because what I'm doing is I'm passing in too large of a value for the y into the output, so it doesn't know what to do. So that's what we're gonna fix here. So I'm gonna change these into if-thens, because I'm gonna add another line of code for each of these. So I'll say if x equals 17, then I'm gonna store 1 back into x. Okay. That way, if I go off the screen, what it'll do is it'll reset me to the other side. So here I'm going to add another if then, and I'm going to add another statement here. So if x gets too low, so if x equals 0, then we're going to store 16 into x. And then for the y's, I'm going to do the same thing. But the y's, the width of the screen is 16, but the y's is the height of the screen, and that's only 8. So I'm going to put in an if statement for if y is 9. in this case, and then I'm going to set it to 1. And then if y is too big, if y is too small now, I need to handle that case. So if y equals 0, then I need to set 8 as y. Okay, so this should work. So if I go up, should be able to wrap the screen, good. Left, good. Down, good. And then right, good. Okay, so now we can travel like anywhere, and if we go too far, we just come on the other side. So now we're getting somewhere. Now we kind of have a problem, we're not erasing ourselves. So what we could do is we could clear the home each time. This would be a really easy fix. But we can't stick with this fix because if we do, we'll end up erasing other things on the screen, and if we move too fast, it doesn't look as good. I guess it's not too bad with the TI-84, but if we put other things on the screen, we'll have to redraw everything. So instead of doing this, we'll actually want to just erase ourselves with a space where we used to be. So in order to do that without erasing ourselves for a long time and then drawing ourselves again, we'll actually have to save our coordinates, because if we erase it like right after we draw ourselves, like right after we move, then every time we move we'll be disappeared for a long time. So we should actually erase ourselves, like to make it look the best, we should actually erase our old self after we draw the new self, which means we might even have to check if we moved at all. So that'll take up some time computing, since we'll have to run this loop a lot during our game, but it probably will be worth it in the end, just because it's one of the most important parts to the game. It'll be the most important. Being able to control yourself is one of the most important parts to a game. So it'll be a sacrifice that hopefully is worth it. So what I'm going to do is, before I change any of the X and Y, is I'm going to come up here and I'm going to store them. So I'm going to store X into S, and I'm going to store Y into T. And then up here I'm going to give S and T starting values, so that we don't try to erase something that doesn't erase something that would actually be off the screen. So S and T are 4. X and Y stores as S and T, so they're getting saved here. Now we check if they're different. Or actually, let's do it after we output the new one. So if S is different than X, or T is different than Y, so if either coordinate changed, then we'll want to erase our old position. Okay, so we're going to output T comma S comma space. Okay, so actually, let me make sure I'm not erasing the screen. Yep, I gotta get rid of that line. Okay, there we go. Now let me show you an example of what this would look like. So if I put, like at 8, 8, if I put we'll put a F right in the middle of this, somewhere on the screen about 8, 8. So it will be at the bottom of the screen, about halfway down. But the F won't disappear. Even when we move. And when we move fast, we'll always be able to see ourselves. Now if we go over the F, it'll disappear. So to fix that, it will actually be even more difficult, because we want to actually save everything. we want to output everything that we run over. We want to erase ourselves with the correct thing, whether it's a space or whether it's just something that belongs there. And so that involves using memory. And because the screen by itself is memory, but it's not very accessible memory. I don't know how to check what symbols are at a certain part of the screen, and even if we walk over that part of the screen, or even if we could check it, if we were to walk over that part of the screen, it wouldn't even be the right symbol anymore anyway. So we have to actually use something like a matrix, and a matrix is like a big array. So what I'm going to do here is I'm going to store the dimensions of a matrix, and I'm going to set matrix A to be the one matrix that we're working with. So I'm going to set it to 816, and that's the same size as the screen. So now we have a number that we can store for every position on the screen. If I go down here, I can set things like I can set 8. I can set F to be the value of that part of the screen. So what we're going to do is we can't really set F the letter itself, but we can set numbers, and then we can associate the numbers with letters. So if I put a 10 as 8, 8, then down here what I can do is I can change this into an if-then. So I have more control over how I'm going to actually erase us. And then I'm going to actually store a string. So we're going to put, we're going to use string 1. If matrix A, anyway, if the old spot in the matrix, so we're going to put T comma S, just to match with the output. If that equals 10, then we're going to store an F. We're going to store that into our string 1. Okay. But before we even do that, we're going to just store a space into string 1, so that if that code never happens, the default will always be a space. So we're going to put a string 1 here, and there. Now if we have a 10 in that position, it'll be an F. If we don't have a 10, if it's anything else, it'll be a space. And here I'm going to actually, I forgot to do one thing. We have to store zeros into like the whole matrix. So store 0 into matrix A. I might have got those backwards, we'll see. Okay, good. Oh, there's our F. Okay, so I actually erased the F to begin with, or I never outputted it, but you saw when I ran over it, the F appeared. So the reason why this is because we're only erasing ourselves with the matrix. We're not drawing out the matrix in the first place. So before we actually get into this loop, after we fill up the matrix right here, this can be more lines of code, not just one. But actually I can put 2 loops, and I'm going to show you how to do for loops, because they're really easy to use for these types of things. So I'm going to put 2 for loops inside of each other, so this is a double loop. Okay? And I'm going to use a couple different variables. We're going to use A and B because we're not using A yet until we get down here. I'm going to store 0 into A here actually, just to be safe. But yeah, I'm going to use A and B. So they're going to go from 1 to 8. A is going to go from 1 to 8. B is going to go from 1 to 16. And we're going to output on the screen A comma B, and then we're going to put string 1, whatever string 1 is. We're going to set string 1 right here though, right before we output it. So actually we're going to set, just like we did before, we're going to set 0, the space is string 1, but we're going to check if matrix A, A comma B, whoops, if matrix A comma B equals 10, then we're going to store F into string 1. Okay, so this should work. Oh, that didn't work. If matrix A comma B equals, hold on, maybe it's because of, it might be because I didn't finish those parentheses. Yeah, that was the problem. Okay, so the F is there. So if I run over the F, it'll reappear. But it's nice because the F is actually there to begin with. So in place of that F, we can actually put like walls and stuff. So instead of just being able to run over the F, actually, you know what? Let's let us run over the F. But let's add another special letter here, and we're gonna make this one a wall. So AB equals, we'll do it 9. Okay, and we're gonna put this somewhere else. So 9 is gonna be stored as, we'll put it at 7, 7. So it's kind of close to the F, just a little diagonal to it. If it's 9, then we're gonna actually output a W, and that's going to be a wall. And right here, we don't need to worry about erasing ourselves with the wall because we're not going to let ourselves walk onto the wall in the first place. So we're going to output, or we're going to check before we change our variables. We're going to come down here, and right after we change our variables, this is how it's going to work. This is a really easy way to make walls. After you change your variables, okay, I haven't done anything with them, I've only changed them, and I have the old ones saved. So as soon as I try to change my coordinates, no matter what the new coordinates are, I can do a check. I can say if the new coordinates, so if A, the matrix, has at these new coordinates, if it has a wall there, then I can just change the coordinates back. So if A, Y, X equals 9, okay, then what I'm going to do, I'm going to put a then because I have to do 2 statements. Okay, so I have to have an end then. And whenever you have a then for an if, you also need an end. Okay, so if I put a, if I have a wall there, then I'm going to set my T back to be my Y and my S back to be my X. Okay. So now when I run it, there should be an F and a W. Okay, so I should be able to run over the F, but the W I should not be able to go on. Oh, here. I'm trying to go down. Now I'm going to try to go right. Can't go. I'm going to try to go up. Nope, can't go. I'm going to try to go left. Nope, can't go. So I just made a wall. Okay, I made a background type character. I can also make moving enemies or items that we can collect that once you touch them, they're no longer there. They're in your inventory instead. I can do plenty of things. But right now, I think that's all the time for it that I wanted to spend on an episode for right now. I'm going to try to keep these about 30 minutes or less if possible. And yeah, that was really fun. We can continue working on Zelda. hopefully we'll make a whole bunch of levels or something interesting like that in the future. So hope you guys had a really fun time watching this, and I hope you enjoy programming and try to do it at home and try to do it for fun, because that's how I've always done it. I've always had fun programming. And I'll see you later.